Hello, my name is Jennifer Hall, and this is a short little video on how to read and interpret a forest plot. So here you see we have two forest plots that were taken from a Cochrane systematic review, and this particular systematic review is Alcoholics Anonymous and Other 12-Step Programs for Alcohol Use Disorder, and that was a review that was conducted by the Cochrane Collaboration in 2020. And this first set of analysis is looking at a comparison between the AATSF group, which is our control group, and the comparison group. So this would be the intervention group. So we're going to look at this first forest plot right here. So this top one. And the first thing that we're going to do is we're going to look at the number of studies that are in the forest plot. So in this first grouping 1.1.1, we can see that we have 4 studies. 1, 2, 3, 4. And the next thing to look at is the total number of participants that were included in the meta-analysis. And we get that by adding these two numbers right here. So 582, that is the total of this big N right here, which is represented on this side of the divide. And then we take this large N, which is represented by these numbers here on this side of the divide, and that ends up at 1,144. So we're going to take 582 and add it to 1144, and that gives us 1726. The next thing to look at is the weight. So that's in this column right here. The weight is basically which study had the most influence on the overall results of the meta-analysis. And oftentimes the study that has the most number of participants is given the highest weight. However, that is not the case in this particular meta-analysis. So this study right here, this Match 1997, this one right here with a weight of 34.84%, is the study that had the most influence on the overall results, although it does not have the most number of participants. So the number of participants in this particular study is 389, whereas the number of participants in this study right here, study number 2, was 486. And you can see that it did not have very much influence on the results. So they must have used a different metric whenever they were determining what the weight was going to be for this particular meta-analysis. And the way that that's represented visually here on this graphic is the size of the box. So I could tell right away that these two studies right here, number 1 and number 3, have the most influence on the results because the box is the biggest. Right? And then the next thing to look at is this risk ratio right here. So this is the p-value and this is the confidence interval for each one of these studies. And that information, this information right here, is represented visually here with this graphic. And so the first thing to look at is where each one of these lines end. So that represents the confidence interval. So the length of the line represents the length of the confidence interval. And then you also want to look at this line right here, which goes right down the center here. And that is called the line of no effect. And that's the point at which our intervention and control are essentially the exact same thing. And so because this is a ratio, that means that our line of no effect is 1. All right. And on another thing to notice is the boxes that are on this side of the line, these right here as well, they all favor the control. So they favor the AATSF outcome, whereas the boxes that are on this side of the line, which is really only this one right here, favor the comparison. So those are, that's our intervention. All right. Okay, so the next thing to kind of look at is this line right here, which is the overall effect of the meta-analysis, and that's represented by this triangle right here. So the overall effect, the overall result is always displayed as a triangle, and its endpoints represent the confidence interval. So you can see that the tip of this triangle crosses the line of no effect, which means that our p-value is not going to be statistically significant. And you can see that that is true. Our p-value is 1.07, and so therefore we do not have a statistically significant result here. And you can see that represented visually here because the tip of the triangle, the confidence interval, goes right through the line of no effect. The next thing to look for is our p-value. So we see that our overall p-value is not statistically significant. We also want to look for the heterogeneity, and we use this information right here to determine that, specifically this I squared. And so heterogeneity is used in conjunction with the null hypothesis. And when you're looking at heterogeneity, what you're really wanting to determine is how alike the studies were. So when they completed this meta-analysis, how similar were the studies that were included in the meta-analysis? That's what this information is really trying to communicate to you. And that is used to determine whether or not we can have a single effect size. So if the p-value is insignificant, which means that it's above 0.5, there is little variation. Most of the studies that were included in the meta-analysis, look very, very similar, and therefore a single effect size can be reported. And we can also see that represented with this I squared. Because this is hovering around 30%, that tells me that we have a small amount of heterogeneity. If the p-value is significant, however, meaning that it's less than 0.5, this indicates that we have limited homogeneity. The studies were wildly different. They had very little in common, and therefore a single effect size cannot be reported, and this makes the results of the meta-analysis invalid. So that is the interpretation of the forest plot, and I will have all of that information typed out for you in the document directly below the forest plots.